Hi, we're going to discuss the cardiovascular effects of autonomic drugs, and what that means is how does the blood pressure and heart rate change in response to various agonists and antagonists that affect autonomic nervous system. Before we do that, let's review over here the cardiac cycle, pressure on the y-axis, time on the x-axis, and you can see we have the left side of the circulation graphed, the aortic pressure being graphed here over time, the left ventricle pressure being graphed over time, and finally the left atrial pressure being graphed over time. Now, if we're going to be looking at the blood pressure responses to autonomic drugs, the graph that we care about here is going to be the aortic pressure. Okay, and it's good to review the key pressures that we're going to be analyzing. And you can see right here that the aortic pressure reaches a minimum right there, and if we take this and identify it, by definition that's called the diastolic blood pressure. So we can write that in here, diastolic blood pressure, or we can just call it the DBP. Okay, and we also see that after the aortic valve opens, which would occur right there where the left ventricle pressure exceeds the minimum aortic pressure, that valve opens up, that begins ejection. The ventricle ejects blood into the aorta, and the aorta expands with that bolus of blood, and the pressure rises accordingly. And where it reaches its maximum, which you can see is very, very similar to the maximum left ventricle pressure as long as there's no aortic valve stenosis, that maximum pressure, which is right here at the peak of ejection, we can follow that along right there. And that pressure is referred to as the systolic blood pressure. Okay, so right here would be the systolic blood pressure. And we can just abbreviate that SBP, systolic blood pressure. Now, another thing we can get from this graph is that we can see that there's the difference between the systolic and a diastolic blood pressure. How much does that pressure go up after the diastolic blood pressure? And that would be the pressure from ejection. That difference between the maximum pressure and the minimum pressure is called the pulse pressure, or we can call this the PP. Okay. Now, another thing I would want to point out is that we can see that this is happening over time. So the pressure falls, and the pressure rises, and then it falls, and then it rises. And over the cardiac cycle, after cardiac cycle, we could estimate the mean pressure, the mean aortic pressure, or mean arterial pressure. And so there is a formula that we can use. It's the mean arterial pressure is equal to the diastolic blood pressure plus 1/3 pulse pressure. Okay? Now we can make sense of this equation by looking at it a little bit differently. We can take this pulse pressure idea and we can say the diastolic blood pressure plus 1/3, and then we can take the pulse pressure and substitute the systolic blood pressure minus the diastolic blood pressure. Okay, and if we expand this out, okay, we have the diastolic blood pressure plus 1/3 systolic blood pressure minus 1/3 diastolic blood pressure. Now what we end up with then is 2/3 diastolic blood pressure plus 1/3 systolic blood pressure. Okay, and the reason why that's interesting is that the mean arterial pressure is biased towards the diastolic blood pressure. That is, most of the time of the cardiac cycle is spent in diastole. It's usually about 2/3 of the time in diastole versus 1/3 in systole. Now that can change with heart rate changes, but a typical normal heart rate, that's generally how much time you spend in each phase. So because more time is spent in diastole, that's why you can see the weighting is a little bit more. Now you may not have been able to appreciate that as much from this original equation, the diastolic blood pressure plus 1/3 pulse pressure necessarily, but this is another way of looking at it. All right, so that is another consideration, is the mean arterial pressure. Now, why do we care about the mean arterial pressure? Well, it's because the baroreceptors that are in your carotid, sinus, and aortic arch, they sense the mean arterial pressure. And that's going to be important as we move along this discussion, that when they respond to that mean arterial pressure, they can then affect the autonomic nervous system through reflexes. So this is why it's important to consider the mean arterial pressure. Now, when we're doing these cardiovascular effects of autonomic drugs, or any other drugs actually, we don't really use a Wigger's diagram to do that. What we do is use a representation like this right here. Okay. Now you can see we have blood pressure above, and we have heart rate below. That is the two considerations, blood pressure and heart rate, that we're going to be looking at as we look at various agonists and antagonists. Now notice for the blood pressure there are 3 lines. Okay. There's a top line, the maximum pressure, a bottom line, that's the minimum pressure, and then there's this line sort of near the minimum line here, and we made it dotted. It's not always necessarily have to be dotted, but that's how it's shown here. And you can see, well, what are those pressures? Well, this represents the systolic blood pressure, okay? This represents the diastolic blood pressure, and this dotted line here represents the mean arterial pressure. Now another thing that's also given in this information is the difference between the systolic and diastolic blood pressure. Remember, that was over here, this pulse pressure. So we actually also can get an idea about the pulse pressure. So there's a number of pieces of blood pressure information that a graph like this will show. Okay. Heart rate, that's just a straight line indicating the heart rate. And what happens, as we're going to see, is when we give a drug, these lines are going to change. The lines for blood pressure, they may change or they may not change. And the heart rate may or may not change. It may go up, it may go down, it may not change. That is going to be what we're going to be looking at, is going to be the changes in blood pressure and heart rate. We actually are not going to be looking at absolute values. You can see there's no numbers actually shown here. We're just going to be looking at the change, and that's how we're going to figure out the identity of the various drugs that we're going to look at. And so the next step is we're going to go further discuss how you go about looking at the changes in the blood pressure and heart rate tracings.